Now let's see what is meant by interference of waves. Now interference of wave is nothing but this is a superposition of one wave above the another. We call it that as interference of wave. So the phenomenon of one wave interfering with another and the resulting redistribution of energy in space around the two sources of disturbance is called interference of wave. If you are asked to write the definition of interference of wave, then you can write it this one. Now I will tell you that there are two types of this interference. The first one is what? Constructive interference, and the second one is known as destructive interference. Now constructive interference is what? When, say, you know that there are two waves here. One is red wave, another is blue wave here. Okay, but here you see that the crest of the red wave coincide with the crest of the blue waves. The crest of the red and the turf of the red wave coincide with the turf of the blue wave. So if such crest and crest, turf and turf coincides, then we say that they are in phase. Okay, so when one crest coincide with the crest, or when one turf coincide with the turf of another wave, then what happened? The superposition principle, due to the superposition principle, the amplitude of the resulting wave will be what? Will be the addition of the amplitude of the individual waves. And so what happened? The resulting or the resultant wave will be having more amplitude. Such type of interference we call it as constructive interference. Got it? And the amplitude of the constructed wave, resulting wave due to constructive interference, it is also expressed here, is denoted by E1 plus E2. And if on the other hand, okay, this here the phase difference is 0, but if the phase difference is equal to 180 degree or pi radian, that means when the crest of the one wave will coincide with the turf of another wave. So this is a crest for a red wave and this is a turf for the blue wave. So they coincided at a point, and so what happened? The phase difference between them is 180 degree, or you can say pi. Okay, so what happened at this time? What happened? The resulting wave, which is denoted by the green wave here, green color, the resulting wave is less than either of these what waves. Okay, or the resulting wave reduces, you can say amplitude of the resulting wave reduces, and it will be given by the difference of the amplitude of the two waves. So E1 minus E2. Got it? So such type of superposition or interfering of wave, we call it that as destructive interference. Here constructive more, destructive less. Okay, so amplitude is less. Got it? So if these amplitude are same, I mean E1 and E2 are of same amplitude, then what happen? Your resulting wave will be what? 0. Okay, there will not be no light wave, and such type of destructive interference will be also happening in the case of Young's double slit experiment that we will be discussed now. Okay, now the red light and the blue light waves are denoted by here first wave, second wave, and E2, which is denoted by the green one. I mean this one, E2 is for this second wave. Okay, for this resultant wave, what happened? It will be denoted by capital E here. Got it? So now this, you will see here those colors with different, okay, crest, turf, okay, here. So what happened? This red, I mean this will be the bright band, and for a dark band it will be denoted by deep green color. And you will see here the light source produced by this S1 and S2. These are the two coherent sources. Okay, and these two coherent sources, turf is denoted by this orange color and your crest is denoted by blue color here. So for this source, blue color here, next turf, crest, turf, crest, okay, turf, then crest, like this. Similarly for the first source also, you will see that crest, turf, crest, turf, crest, got it, turf, here like this you will see crest and turf, crest and turf. Okay, so these two will keep on emitting this light wave continuously. So what happens when you interfere at a point, okay, the light waves coming from one source and another coming from another source, if they interfere, there will be constructive as well as also destructive. Wherever there is constructive interference, you will see as a bright. See, you will see that crest turf of one web from the source S2 and another coming from the source S1, they interfered here. So this is also for crest, crest, turf, turf, crest of one web coming from source S1 and S2. This is also turf coming from S1 and S2. Likewise, these are all crest, crest, turf, turf. That means crest, crest, turf, turf, crest, crest, turf, turf, here like this. So this will give you the bright color. But here when you see here, this is crest coming from the second source and crest coming from the first source and turf coming from the second source. This blue and orange, they interfered here. Blue and orange interfered here. Let me zoom it a little bit so that you can see easily. Okay, so here orange, orange, blue, blue, orange, orange, blue, blue, here like this. So this will be having that constructive interference. But here it is dark. Why? Because it interferes with that of crest and turf. That means destructive interference happens here. See, blue and orange, crest and turf. Crest coming from the source 1 and turf coming from the source S2. For this also here, crest coming from the source S2 and turf coming from the source S1. See, you will see red and orange, blue 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 and orange. Have you seen? So this will be having what? That destructive interference. Here you will see as a constructive interference, destructive interference, constructive interference. So likewise, what happened when the light source coming from a two source, it emits out continuously, and what happened? There will be a redistribution of energy. Okay, and that phenomenon of redistribution of energy due to the superposition of two coherent sources which are placed close to each other, we call it that as interference. Got it? If you place a screen on it here, then you will obtain as bright fringes, bright fringes and dark fringes, like that. Alternate dark, bright, alternate dark, bright will be obtained, and those obtained on the screen due to this interference, we call it that as fringes. Okay, let's try to learn about this in the next slide. Okay, let's see. Now this is a theory for interference, okay, of waves, light waves I should say. Now as your light wave is a sinusoidal wave, we can express it as E1 is equal to what? A sine of omega t, where E1 is the instantaneous value of the electric displacement. I told you that electric polarization of light happens only due to this electric field. Okay, electric field vector is more important than of the magnetic field. Why? Because this polarization and vibration of light wave, it is due to this electric field only, not with that magnetic field. So your instantaneous value of the electric displacement or light displacement of light from the first source, let it be denoted by E1, and it is equal to A sine of omega t, where A is the amplitude of that of the first wave, and omega is nothing but this is the angular frequency, and t is at any instant of time t. Got it? So let this be the displacement, okay, of the first light wave, and E2 be the displacement of the second wave, and so it is equal to B sine of omega t plus phi. What is this B? B is nothing but this is the amplitude of the second wave, omega is the angular frequency, time is at that time, and phi is the phase difference between the first wave and the second wave. Got it? So applying a principle, superposition principle, the magnitude of the resultant wave will be the sum of the individual displacement of the two waves. So E will be equal to E1 plus E2. Then you try to express it, this A here sine omega t for E1, here B sine of omega t plus phi for E2, And if you do that simplification by using that, sine of a plus b is nothing but this will be equal to sine omega t cos phi plus cos phi plus cos phi into sine omega t. If you do it that expression here and if you rearrange it, then it will be obtained like this. From where it is coming out, you just see. Now this b sine of omega t, right? If you express it, then it will be what? B times of what? Sine of omega t cos phi, okay? Plus cos phi sine of omega t, like this, no? Then you try to associate having those of sine omega t, one here and another here. Got it? So then what happens if you take sine omega t common from this expression, then sine omega t, if you take it common, then it will be a plus b cosine of omega t will be there, right? Got it? That is what I have written here. Got it? And what remains is what? B times of what? Cosine phi sine of omega t, that is here. Got it? So let's try to put it in a different way. See, then by putting what? You try to put this a plus b cosine of phi as a cos theta. Let's try to put it. Instead of this, let's put it as a cos theta. Instead of this b sine phi, you put it as a sine theta. Okay, we should not put it that having t here, that having t here. We should put it that without having t. Okay, without having that t. That means which is not a function of t. You need to put it that one. Okay, so a plus b cosine of phi, you put it as a cosine of theta. B cosine of b sine of phi as what? A sine theta. After putting it and after rearranging it, then it will be equal to what? A sine of omega t plus phi. Okay, if you put it that expression here, if you try to put it this as a cosine of theta, then it will be equal to what? Let me write here. E will be equal to what? A cosine of theta, okay, sine of omega t plus, instead of this b sine phi, you put it as a sine of theta, then cosine of omega t, like this, right? So you take a common here, and if you try to express this within the bracket, this plus this is nothing but this will be what? Sine of omega t plus theta. If you try to expand it this, then you will get these two terms, right? That is what it is given here. Okay, so that is what it is given here. So this resultant displacement E, okay, resultant displacement of the resultant wave, this is coming out to be as a sine function again. That means after superposition, the resultant wave will be sinusoidal again. It will be just acting just like the progressive light wave. Okay, and this theta is what? This is a phase difference between that of the first light wave. Okay, the resultant wave is having phase difference theta with that of the first wave. So we can easily find out the amplitude A, we can easily find out the phase here phi, theta also, by doing what? If you name it this as equation 1, if you name it this as equation 1 and this as equation 2, squaring and adding, okay, squaring and adding this equation 1 and equation 2, then you can easily get it this A as like this. Got it? You try to do it by yourself, and if you divided this equation 2, okay, this equation 2 by this equation 1, then you will get it that theta. Theta will be equal to what? Tangent inverse of b sine phi divided by a plus b cosine of phi, like that. Okay, so if you divided this equation 2 by equation 1, then you will get it this one. Squaring and adding, you will get it this one. So whatever we have put, that expression a theta can be obtained from these two equations. Got it? And if you want to do in terms of that of the phasor diagram, okay, you can do it from here. Okay, this is what we have done. Your A is here, B is here, angle between them was phi, right? This phi, so that phi is here, and the resultant web is here, and the angle phase difference between what? Your resultant web and the first web, that is what? Denoted by theta. It is all depicted here. Okay, let me show you. Yes, you can see it easily here. Got it? That is how you can express it in terms of phases. Okay, I mean phasor. Now let's see that one in the next slide. Yes, so your amplitude is equal to root over of a square plus b square plus twice ab cosine of phi. If the amplitude of the two webs are same, then what happen? It will be what? A square plus b square plus twice ab cosine of phi. Okay, in that case what happen? This b will be equal to a. Got it? Now we know that intensity of any web is directly proportional to the square of the amplitude. So what happen? Your amplitude square will be equal to or directly proportional to the intensity. So intensity, we say that for any web, intensity of the web is directly proportional to the square of its amplitude. So if you want to express it, your intensity, then intensity I is directly proportional to what? A square plus b square plus twice ab cosine of phi, by taking that squaring of this. Okay, so this is very important. From here only we need to find out the condition for interference, constructive interference, destructive interference, then fringe wide, all will be coming from this expression. Okay, now this condition for constructive interference, in the case of constructive interference, the portion of the light should be what? Bright. Got it? For destructive interference, it should be what? Dark. Constructive interference, it should give more brighter, that means light should reach. Got it? So for constructive interference to occur, what happened? This intensity I should be what? Maximum. Okay, maximum intensity should be reaching there. So we said that that intensity is what? Maximum. So to have this intensity maximum, what happened? This A, B, these are all constant. Why? Because this is the amplitude of that first wave, B is the amplitude of the second wave. So likewise AB2 is a constant, so it depends upon this cosine of phi. So in order to have maximum intensity, what happened? The maximum value of cos phi must be there in this intensity. So we know that cos of any angle varies from what? +1 to -1. Okay, +1 occurs when it is at 0 degree, twice pi, 4 pi, 6 pi, like that. And -1 is having the value when the angle, this phi is what? 180 degree. Okay, that means pi, 3 pi, 5 pi, 7 pi, odd multiple of pi, I mean. Okay, so we need to do it from that condition. So in order to have that what constructive interference, this cos phi must have +1 value. +1. Okay, cosine of that angle comes out to be +phi when this phi is what? Multiple of twice pi. Okay, it will be having at 0 value also. Sorry, when it is 0 degree, this is 90 degree, this is pi or 180 degree, this is thrice pi by 2, you can say, or this is what? Your 270 degree, and this is your 360 degree, that means twice pi. Okay, when it is here, cosine of 0 degree is +1, cosine of pi will be -1. So what happen when this is at 0 degree here, it will give you 1 value. When it is here, it will give you a 0 value. 90 degree, when it is coming here, it will give you -1. When it is coming here, it will give you a 0 value. When it goes here again twice pi, it will give you this +1. When it is coming to that of what, this 3 pi, okay, when it is a 3 pi, it will be having this. When it is again this as 4 pi, it will give you +1. When it is 5 pi, it will give you -1, like this. So if you keep on rotating like this, the angle, okay, phi, when it is of this what, whole number multiple of twice pi, you can say, you will give you value 1. When it is what, odd multiple of pi, then it will give you -1. We need to know these two conditions for this, okay. So that's what we require it. Let's see. Now see, when it is equal to what, phi is equal to what, even multiple of pi, you can say, or whole number multiple of twice pi, then it will give you +1 value. When you can express it, that formula, general formula, as twice n pi, where n is equal to 0, 1, 2, 3. When you put 0 is equal to n is equal to 0, here phi will be equal to 0. Phi 0, that means cosine of 0 degree will be what, 1. When you put 1, that means cosine of twice pi, okay, that will also give you 1 value. When you give n is equal to 2, cosine of twice 4 pi, I mean, it will be equal to what, 1 value. So this is what you are having, the constructed interference when this phi is equal to what, twice n pi, where n is equal to 0, 1, 2, 3. And the corresponding path difference can be expressed as what, this lambda by twice pi into twice n pi. Now for this, let me explain you, okay, you need to listen me carefully. Now we know that for a wave, let me draw it, okay. For a wave like this with a crest and turf, this is for one complete what, oscillation or vibration, and the length of this one complete oscillation or vibration, we call it that part as wave length, lambda. And for this, it is what, your pi by 2 in terms of angle. For here it is pi, this is thrice pi by 2, and here it is twice pi. So your phase is how much? This is twice pi. Got it? So what happened when a phase difference is twice pi? Path difference is how much? When a phase difference is twice pi, when a phase of twice pi is there, path difference is lambda. When a phase difference is pi, okay, your path difference is denoted by delta x, but here in my what slide, it is denoted by only delta, okay. This is a matter of notation only. You can either use delta only alone, okay. So if your phase difference is what, phi, the path difference will be equal to what, lambda by twice pi into phi, like this. Got it? That is what it is written. It is written I think I have back to the next slide. Let me move to that next slide, like this. So what happened, as I said, let me draw it again, okay. For a path difference, this path difference, the length between these two from here to here, that length we call it as lambda, okay. And this is known as the path difference between these 2 points, okay. So these 2 points here and here, the path difference is lambda. So for a path difference lambda, phase difference is what, twice pi, okay. As I said, for a phase difference of twice pi, your path difference is what, lambda. So for a phase difference of pi, your path difference will be equal to what, you multiply these two and divided by this, so it will be lambda into what, phi divided by twice pi. That is what it is written here, okay. Here means here your path difference is what, lambda divided by twice pi into phase means what, this twice n pi. You can write, instead of like this, you can write like this also. As I said, for a phase difference phi, okay, not it of writing like this, better to write in this way. For a phase difference phi, path difference is lambda. For a phase difference of, I'm sorry, this will be twice pi. Okay, for a phase difference of this, path difference is lambda. So for a phase difference of phi, we don't know this phi. Okay, your path difference, for a phase difference of twice pi, path difference is lambda. For a phase difference of phi, path difference, which is denoted by delta x, will be equal to what? Lambda by twice pi into phi. So we need to put this phi as this, okay, and we need to express it. So what happened? This delta, okay, which is denoted by here delta x, this will be equal to what? Lambda here divided by twice pi here into that phase phi. Got it? So this is the formula that we are doing. For a phase difference of twice pi, this is 0, this is pi, this is twice pi, this is lambda by 2, another lambda by 2, 1 lambda by 2 plus 1 lambda by 2, the path difference will be lambda. Okay, for a phase difference of twice pi, path difference will be what? Lambda. That is what I have written. For a phase difference of twice pi, path difference will be what? Lambda. For a phase difference of pi, the path difference, which is denoted by delta x, will be equal to what? Lambda into phi divided by twice pi. Got it? That is what we have done. So your path difference will be what? If you cancel this twice pi, then it will be equal to path difference of what? N lambda. That means suppose from a wave, okay, coming from this source S1, for example, this is S1 and from here it is S2. Okay, so if these two waves, okay, one coming from here and another coming from here, if the path difference is multiple of lambda, okay, then what happened? Surely one crest, okay, will be coming like this, another crest, okay, if it is like this, then what happened? It will start crest, here also it will start crest. Got it? Then crest and crest will be coinciding. Got it? So the path difference should be always multiple of lambda between the two sources, so that they will have crest and crest, turf and turf interfere with each other. That is a meaning. Okay, so whenever the path difference is what? Multiple of this lambda, then what happened? There will be always a constructive interference, and so what happened? Your maximum intensity will be what? The square of the sum of the two amplitudes. Okay, this one, it will be always there. Okay, likewise for destructive interference of wave, what happened? Cosine of phi will be what? -1. Got it? Cosine of phi, as we have done that one, for constructive interference, your phase difference would be what? Odd multiple of pi, where n is equal to 0, 1, 2, 3, so on. And the path difference will be what? As we did in that case, you put it that pi here, that means pi means odd multiple of pi, then what happened? It will be odd multiple of lambda by 2. So what happened? When one wave coming from here like this, okay, another wave coming from here in this way, got it? That means one turf and crest will be coinciding. What is the phase difference between these two? One is starting from here, another is starting from here. The phase difference is what? 1 lambda by 2. 1 lambda by 2. If you put it n is equal to 0 here, then you will get it 1 lambda by 2. In that case, it starts the first mode of vibration. That mode of vibration, what type of vibration? Destructive interference will take place. Okay, because from the first wave it is turf, from the second wave it is having the crest. So crest and turf will be coinciding, and so you will get it that destructive interference there. Okay, now this is about the comparison of intensity of maximum and minima. Okay, now we know that the maximum intensity is directly proportional to the sum of the amplitudes, square of the sum of the amplitudes. Okay, in that case of minimum, it will be difference square of the difference of the amplitudes. So if you take the ratio, then you will get it like this. where R is nothing but this is a ratio of the amplitude of the two wave. Okay, R is equal to A by P, which is nothing but the ratio of the amplitude. You can express it in this way also. Got it? And if you want to express it, this intensity in terms of the width of the slits, okay, slit of the two source, okay, then it can be expressed that intensity is directly proportional to the square of the amplitude. We know it. And this amplitude is again directly proportional to the square root of the width of the slit. Okay, that slit means what? When you try to have that cardboard, and if you take it a small hollow portion, then this hollow portion of the cardboard opaque object, we call it that as slit, and the white means the white of this hollow portion, that is denoted by W. Okay, your amplitude is directly proportional to the square of this white. Okay, so if you express it all those things here in this expression, then you will get it that your intensity, okay, of the two wave is directly proportional to the width also. Intensity of the first wave is directly proportional to the width of the first slit. Second, intensity of the second source will be also directly proportional to the width of the second slit. Okay, that is how we can express it. Okay, in terms of width of the slits, intensities in terms of width of the slits. Got it? Likewise, this is the Young's double slit experiment. This is nothing but this is the treatment how we can find out the fringe width and all. Okay, let's take it that S is a source. This is a single slit so as to produce the two coherent source by means of two double slits. So we call it this as Young's double slit experiment. Why we are having one single slit here? So as to produce that coherent source. Okay, that two coherent source is possible by means of double slit. This double slit, the light approaching to this double slit is not from two source, rather it is coming from a single source. So this source, light source, will be coming from here. Okay, then what happened to here also? So these two sources will have same amplitude, same frequency, and if they are not having the same phase, rather they will have constant phase difference. Okay, so they are constituting what? Two coherent source, we can assume in that way. So the path difference, one light coming from the source S2 and coming from the source S3, these two slits can act as two coherent source. Okay, so one coming from S1, another coming from S2. The path difference means the difference in the path. From S1, this is the path S1P. From S2, the second source, this path will be S2P. So difference in path, we call it as path difference. That is what it is written here. So to do this, what happened? We need to take it a small assumption that whenever there is a sum of these two, as these two are very close to each other, we can take it that this S1P and S2P, for the sum, we can take it that they are approximately same, but we can't take it in the case of difference. Okay, so S2P square, we need to take it this S2P square minus S1P square will be equal to what? This is just like A square minus B square. So A minus B square will be what? A minus B whole into A plus B. But by taking this right triangle here, okay, the distance between the slit and the screen is denoted by capital D, and the white, okay, and white, or you can say the distance between the two coherent source is denoted by small d. So half of it will be the central portion of the screen. Okay, this half of the d, okay, small d will be d by 2, where this O is nothing but this is a central point of the screen. Okay, now this distance, okay, OP, let's denote it by Y. This is a portion where you will obtain the bright fringe or dark fringe from the central point. Okay, we will find out at what distance will the image on the screen be bright or dark due to that interference. Okay, we need to find it out. So to do that, what happened, let's try to have this right triangle here. Okay, it is not mark anything here, but let me mark it as, say, Q here. So Q, this, there is a right triangle here, you see now. So this S1P, if you take it this as a hypotenuse square, then this will be equal to what? S1Q square plus PQ square plus PQ square, like this, right? So your S1P is nothing but this is equal to D, and this PQ is nothing but it will be Y minus D by 2. Okay, from this Y, if you subtract this Y by 2, then you will get it this portion. Am I right? So likewise, if you do it, then you will get it in this way. Got it? Y, this is for that S2P, for this one. Okay, so for this one, the first one is here. For that I have told you that Y minus D by 2, it is here. This is for S1P square, and this is for S2P square. Got it? If you do it that, then what happen, you will get it these two as what? S2P, as I told you that these two are very close to each other. S1 and S2 are very close to each other, and sometimes we require that S1P will be taken approximately equal to S2P whenever required. Okay, that is done here, and this will be again approximately equal to what? The distance between the screen and the slit. Okay, the point here that we take it that as P, that P is also very close to this central point O. Got it? This point P is also very close to this central point of the screen O also. So sometimes we will require that S1P is approximately equal to S2P, and it is also approximately equal to D. So after taking all those things, then what happened, we will get it as what? This S2P minus S1P is nothing, the path difference that we denoted by delta. Got it? So, and this will be equal to D plus D, it will be twice D, right? S2P is approximately equal to D, S1P is also approximately equal to D, capital D I mean. So D plus D will be twice D, will be equal to what? Twice YD. Okay, so 2 cancel, and you will get it that path difference will be equal to what? Y small d by capital D. Got it? So if you take it that fringe white, position of the bright fringes, for bright fringes at P, what happened? Your path difference, which is expressed as Y small d by capital D, will be equal to what? Integral multiple of lambda. And in the case of destructive interference, it will be what? Odd multiple of lambda by 2, right? So if you do it that value by putting n is equal to 0, 1, 2, 3 subsequently, then you will get it y0 will be equal to 0, y1 will be equal to here capital D by lambda d by small d. Okay, you need to put it only that those values. For n is equal to 0, it will be equal to 0. For n is equal to 1, you need to put it 1 here, then it will be equal to d lambda d. When n is equal to 2, you need to put it here 2, so it will be twice lambda d by d, so on up to the nth terms. Okay, for similarly here also you need to put it that path difference here, n is equal to 0, 1, 2, 3 like that, and you will get it like this. So for a path difference, okay, in the case of destructive interference or dark fringe, you will need to take it this as y0 prime, so as to differentiate from this y0, y1 here, y1 prime. You will see that now for any, let me draw here. Okay, suppose if this is the screen and this is a central bright one, then dark, okay, bright, dark, like this. Okay, you will get it in the screen like this. Suppose if this is a central point on the screen, which is denoted by O, and this y1 is for the y0 is here, okay, and y1 will be here, y2 will be here. Got it? I mean this y1, y0, y2, I'm just marking. Okay, And for that of the dark one, see, this is y naught, okay, prime, y naught prime here. So your y naught prime will be at this one, this will be y naught prime, and this will be what, y1 prime, so on, it will be y2 prime, like that. Now the difference of these any bright fringes, okay, the difference of these any bright fringes, okay, it will give you the white of the dark fringes. Got it? This to be noted very carefully, okay. The distance between any two consecutive bright fringes will give you the white of the dark fringes. Got it? So for a dark fringes, what happens, you need to take any consecutive distance of this, and if you take it, the difference of these two, you will get it the white of the dark fringes. So if you take it these as the dark fringes, then you need to take it the difference of this. So you can take it as y, you can take it as a general formula like this, yn minus 1, okay, or rather if you take it the difference of these two also, got it, y1 minus y0, then you will get it what, d lambda, capital D lambda minus small d minus 0, means you will get this thing. That is what it is obtaining here also. Got it? And if you take it for the bright fringes, the white of the bright fringes will be given by the difference of any two consecutive dark fringes. Got it? The consecutive distance of dark fringes. So if you take it the difference of these two, then you will get it the bright fringe white, or white of the bright fringes. If you take the difference of these two, then capital D lambda divided by 2d, these are common, okay. So what, if you take a difference of this, that means it will be what, y1 prime minus y naught prime. So if you take it, then what happen, it will be capital D lambda by twice d, these are common. So 3 minus 1, I'm sorry, 3 minus 1 is 2, right? So this, within this bracket, it will be 2 will cancel, and you will get it what, lambda capital D divided by small d. That is what it is obtaining here. Got it? This need to be understood. So what happened, as I said, I'm repeating again, the white of the dark fringe will be given by the distance of any two consecutive bright fringes. For white, okay, for the white of the dark fringes, it will be given by the difference of any two consecutive dark fringes, distance of any two dark fringes. For the bright, what happened, you need to take the difference of the distance of any two consecutive dark fringes. But these white fringes, white, okay, white of the dark fringes and the white of the bright fringes, they are almost same. Got it? That is what it is seen here also. Got it? Now let's see, for the distribution of the intensity, okay, for that of the destructive interference, it will be equal to 0. That it will be depicted by these points, and these are for the bright fringes. If I am going to draw it in a very let's try to zoom in first, and then I will draw it, okay. If you try to draw it, then this, if this is a screen, okay, if this is a screen, then this portion will be dark, this portion will be bright. That means for this one, this will be bright, okay. This point is having highest intensity, so this point will be bright, but this one is having what, intensity 0, so this will be what, dark. If I'm going to draw it, then this will be dark, like this. This will be bright, dark, dark, okay, here like this, dark, in this way, okay. So this, the central point which is denoted by O here, okay, this will be bright. Got it? And it will be flanked by alternate bright and dark, bright, dark, bright, dark, like that. Bright, dark on both sides. This will be bright, okay, This will be dark, bright, dark, bright, dark, like that. It will go on continuing like this alternately, okay, on both sides of the screen. Got it? So what happened in the case of these interference pattern, all the bright fringes will have the same intensity irrespective of the central bright spot or the first maxima. We call it these as first maxima. Here and here, this is for first maxima, okay. That means it will give you a bright spot. We call it these two as what? Bright maxima, or you can call it first maxima, and we call it these as what? The first minima. Got it? This as second maxima or second bright spots. These two will be called as what? Second minima. Minimum. Okay, minima means it comes from minimum. So having what? Least intensity or dark, you can call it. Okay. If the two intensity, if the two amplitude of the two waves are same, then it will be almost dark. Got it? So bright and dark interference fringes will be seen flank from the flank on both sides of the central portion of the screen. Okay, that is what. So in the case of interference in the Young's double slit interference pattern, what happened? Intensity of the bright spot or bright fringes will have the same intensity, and it will be also of equal width. Okay, that are all depicted here. Okay, you just try to read it and you go through it. Okay, by pausing the video you can go through it, but for me in order to not to take much time, let me go to the next slide. Like this is for the way the color thin film of oil, okay, it produces just like that of the what alternate bright fringes, dark fringes, but in the case of sunlight it consists of 7 colors. So we will see just like a beautiful pattern of just like that of the rainbow. Okay, we will see the color portion of the different color of the screen onto the oil film. How it is possible, that is shown little bit here. Okay, so color in the thin films, okay, it may be oil film or it may be in the what detergent or soap bubbles also, you can see it like this. Now the light ray, what happened when light is incident onto this, you take it this as a oil film, okay, having refractive index mu. Light ray incident on it, it will be reflected from the first upper surface. It may be refracted from the what lower portion of the oil also. When these two are having the path difference, okay, and the light coming from here, it is also coming from the reflected light and the refracted light, these are coming from the same source, so they may have that interference pattern. Okay, and you will see as a colorful colors. Why? Because in that white light coming from the sunlight, it consists of 7 colors, so it will have to be seen as different colors. If it is of monochromatic, only a single light color, then what happened? We will not see those colorful different colors. Okay, it will be seen only one single color if it is of monochromatic one. But in the case of interference, Young double slit screen and double slit interference, we need to take it only monochromatic light. Okay, but here it will be of sunlight and it will be seen with different colors. Okay, because this is not monochromatic, rather this is 7 chromatic, I should say. Okay, 7 colors will be there. So your path difference will be equal to what? Twice mu t cosine of r, where mu is nothing but the refractive index of the oil film, okay, or thin film you can say, and then t is the thickness of the film. Then what happened? We know that when light is reflected here, okay, from this thin surface, the phase difference between the incident and the reflected light, it is having a phase difference of pi radian. So what happened in the terms of path difference, it will be having what? Lambda by 2. So the light coming from here, okay, with this reflected one and the refracted one will be having what? The path difference of what? N plus 1 by lambda by 2, where n can be of any value. Okay, but there will be odd multiple of lambda by 2 here. Got it? So for the rays OA and BC, what happened? To interfere or to have that constructive interference or bright fringes, what happened, the path difference must be what, n plus 1 by 2 times of this lambda. Okay, I told you that it should be a multiple of lambda, but here it will not be whole number multiple, rather whole number plus half. Why? Because already half has been their path difference, because this is due to the reflection. Okay, the path difference will be of what, 1 lambda by 2 will be there. Got it? For that one we are having here 1 half here. Got it? So you try to express this path difference and you try to correlate with this. Instead of n lambda, it will be n plus half must be there. Why? Because for that incident and the reflected light, phase difference is of pi radian. Okay, so in terms of path difference, it will be what, half must be there, half lambda by 2 will be there. Okay, so for that we are taking here, and for that of this destructive interference, it will be what, lambda by 2. Okay, so there is always a difference here. It will be odd multiple of lambda, and for destructive it will be what, it will be multiple of lambda. Okay, so it is also seen here that whatever I have told you here, beautiful rainbow colors are formed due to the interference of light. Okay, got it? Yes, with that we will come to the end of today's class. Okay, thank you.